Hi everyone, in this video we're going to review grade 10 equations. Now please note, if you haven't started equations yet at all, this video is not for you. It's rather a summary of all the equations done in grade 10 and is best listened to at the end of the section. Here's what we're going to discuss in the video. First we'll discuss types of solutions. Next we'll do examples involving first degree equations and quadratic equations and equations with fractions. Finally, we'll look at literal equations, the kinds of equations where they say, make x the subject of the formula. When you start solving an equation, it's helpful to consider how many solutions the equation will have. Now in grade 10, we focused on two kinds of equations, first degree equations and second degree equations. Now first degree equations have the highest power of x being 1, and second degree equations or quadratic equations will have the highest power of x being 2. Now, a first degree equation will have up to one solution. Second degree equations will have up to two solutions. They could also have one solution or no solutions. Which brings us to discuss identities. Now, identities are situations that are always true no matter what x is or no matter what my unknown is. So, for example, if I had 2x plus 5 is equal to 2x plus 5. So somehow I've solved the equation, I get 2x plus 5 is equal to 2x plus 5. Surely any value for x would be true, so I could say x is an element of the reals. Or here's another example. Let's say I had 5 in brackets, x plus 1 is equal to 5 plus 7x minus 2x. And I work out the left and simplify the right. Can you see I land up with the same value on both sides? So surely x could be anything. In other words, x is an element of the real numbers. Now, if I go back to my first example for identities, and I change the number, so now I've got 2x plus 5 is equal to 2x plus 4. If I simplify that, I'd have 1 is equal to 0, which is impossible. So this situation is completely impossible to happen, and I'd say no solution. Or if I have x squared is equal to negative 4, there's no two numbers I can multiply together to give me negative 4. So I'd say to that equation as well, I could have no solution. So remember, it is possible to have no solution or to have an identity where any solution works. But generally, first degree equations are going to have one solution, and second degree equations or quadratic equations will have two solutions. So we'll look at a few examples of first degree equations. You should have done many equations like this in previous grades, so I'm not going to spend a long time with them. Now I know these are first degree equations because when I look at the x, there's no power written down next to them, meaning the power would be 1. So the way I normally solve these is I group my x's on one side and the constants on the other. So let's say negative 5x minus 2x, and I group my constants on the right, negative 6 minus 8. Or if you want to, you could group your variables on the right and your constants on the left. Next, I simplify each side, so I get negative 7x is equal to negative 14. I divide both sides by the coefficient of x, and I get that x is 2. So the big idea with solving first degree equations is you want to group your variables on one side and constants on the other. Let's look at example 2. Let's firstly remove the brackets by distributing. So I'm going to get 3x plus 6 plus 2 is equal to 5x, and I'm going to multiply the negative 2 into that bracket, minus 2x plus 8. Let's simplify the left. I get 3x plus 8, and on the right, I'm going to get, I left that x off, 5x minus 2x gives me 3x plus 8. Now, can you see the left and the right give me identical values? So this is what we call an identity. Any value that I put in for x will make the equation true. So I say my solution is x is an element of the real numbers. Now let's look at examples of quadratic equations. Now with quadratic equations, your exponent will be a 2, or your power will be 2. So when I solve these, I'm going to have up to two solutions. So something you must be very careful of is you can't just say x is equal to 5 by square rooting both sides. That is not going to work because you're going to lose a piece of information. So rather, my suggestion is that you bring everything to one side. So I'm going to now have a difference of two squares, x plus 5, x minus 5 is equal to 0. Therefore, x plus 5 is 0, or x minus 5 is 0. So I get x is negative 5, or x is 5. Now, the important thing with quadratic equations is that you want to create a situation where you can have a product equals to 0. So the important thing when solving quadratic equations is put everything on one side. And so I'm setting everything equal to 0, and then I'm going to factorize. And then I solve each factor to solve the equation. Now let's go back to what I said at the beginning. What if you try to do this equation like this? X squared is 25, and you try to square root both sides. You can actually do it that way, but what you must remember that when you square root both sides is that there are two possible answers. 5 times 5 is 25, and negative 5 times negative 5 is positive 25. So if I do it that way, I could do it a slightly shorter way, but you must be careful not to forget that you have a plus minus sign there, meaning that you have two answers, x is 5 or x is negative 5. That brings us to the next question. Now let's think carefully. I need to have two values that multiply together to give me negative 25. If I was to do it the way I did the previous question on the right, x squared is equal to negative 25, and I root both sides, I've got a problem because I can't find the square root of negative 25. So here I'm going to have no solution. Similarly, if I brought everything to the left, you cannot factorize this. So therefore I have no solution. Most of the time, quadratic equations you get, you'll be able to calculate the solutions. But however, there are some where there is no solution. Let's look at two more quadratic equations. So in example 3, I'm solving for x. I can see that my equation is quadratic. So my standard way to go about quadratics is to bring everything to the left. So I'm going to say 5x squared minus 20x is equal to 0. And then I'm going to factorize. This one I've got a common factor of 5x is x minus 4 is equal to 0. So I get two solutions. 5x is 0, or my other solution, x minus 4 is 0. So now if I divide both of these by 5, I get x is 0. And here, if I add 4 to both sides, I get x is 4. So my two solutions are x is 0 or x is 4. In example 4, I've got a product is equal to 24. Now, I don't know what these two brackets will be to make 24. It could be 12 and 2. It could be 24 and 1. So I don't want a 24 on that side. I need 0 on one side. So firstly, I'm going to multiply out my brackets. I get x squared minus 7x plus 3x minus 21. And I will put the 24 on the left by subtracting 24 from both sides. So I get x squared minus 4x is negative 45 is equal to 0. Now I can factorize. I know that I'm going to have one positive. Since 45 is negative, I'm going to have one plus and one minus. And so 45 is 9 by 4, so 9 is negative. Sorry, 9 by 5, and 5 is positive. So then I'm going to say that therefore x is negative 5 or x is positive 9. This brings us to solving equations with fractions. Now, equations with fractions could end up being first-degree equations, or they could end up being quadratic equations. However, once they still are in fraction format, it's a little bit hard to see what's going on. So generally, the strategy for solving equations with fractions is to give everything the same denominator and then multiply both sides by the lowest common denominator. So let's just make a note there quickly. Multiply both sides by my lowest common denominator. Now, if I look at the first example, the way it's written is not that friendly. So let's rewrite it. So my first term is divided by 2, so I'm going to get 3x plus 2. My second term is dividing by 3. In the numerator, I'm going to get 2x minus 1. And my last two terms don't have a fraction, but I like to write numbers like this over 1, just so that I don't forget to give them all the same denominator. Now, if I look at my denominators, I have 2, 3, and 1. My lowest common denominator is going to be 6. So in this example, I'm going to show changing each denominator so that it's 6. Now the number 2, to get to 6, I'm going to need to multiply by 3. So to keep my equations equivalent, I'll be multiplying by 3 over 3. So I get 3 multiplied by 3x plus 2. In the next fraction, I've got a denominator of 3. So to make my denominator 6, I'd need to double the top and the bottom. So I'm going to get 2 times 2 gives me 4 times by x minus 1. And the last fraction, I have a denominator of 1, so I need to multiply that denominator and numerator by 6. So that means I'm going to get 6 times by 2x minus 3. Now, since I have an equation, I've got two sides. And what I do to one side, I can do to the other side. So something that will make my equation easier to work with would be to not have a denominator. So what I'm going to do is I'm going to multiply both sides by my lowest common denominator. And that will make my denominators fall away. So that gives me, and I've got to distribute out at the same time, 9x plus 6 minus, careful of this minus, 4x, negative 4 times negative 1 is plus 4, is equal to 12x minus 18. Let's just neaten things up here a little bit. 5x plus 10 is 12x minus 18. Let's bring our x's to the right. So I'm going to get 7x, and 10 plus 18 is 28. Divide both sides by 7. And I get that x is 4. Now what you'll find, the more of these questions you do, you'll find that you can normally skip this step. And straight away, go from my second step to my fourth step. However, if you feel like you need to, you can still do that red step so you don't make any mistakes. In the next example, things look a little bit more complicated. Now to choose the lowest common denominator, it'll be best to first factorize each part so I can choose the factors that will work best. So let's start by factorizing. That's a difference of 2 squares in the first fraction, so I'm going to get x plus 1, x minus 1. My next fraction has a trinomial as the denominator. So let's factorize that. That will be x plus 2, x plus 1. And the last fraction, if I look at the denominator, it is a switch around of other factors I already have. So let's make my life easier and switch it back around. Remember, you switch around by changing the sign, x minus 1. Now I need to find my lowest common denominator. Now my lowest common denominator needs to ensure that all the factors can fit into it, and each denominator will be able to fit into the lowest common denominator. So firstly, for the first fraction, I'm going to need an x plus 1 and an x minus 1. In the second fraction, I need an x plus 2, but the x plus 1 is already included. And in the third fraction, I need an x minus 1, which is already there, so I don't need to write that one down. Now, I'm not going to show the step where I make all my denominators the same. Rather, I'm going to skip that step. I'm just going to show the step where I have the numerators. So in the first fraction, to make the same denominator, I would need to multiply top and bottom by x plus 2. So I get 2x plus 2. In the next fraction, to make the denominator the same, I would need to multiply top and bottom by x minus 1. And in the last fraction, I'm going to need to multiply top and bottom by x plus 2 and x plus 1. Now I'm going to solve my equation. So on the left, I get 2x plus 4. Let's just simplify this. On the right, x minus 1 plus the trinomial, which is quite easy to do because that's the question I had at the beginning, or the denominator I had earlier. So I'm going to get x squared plus 3x plus 2. And so let's see. It looks like I've got a quadratic equation, which means everything will need to be on one side of the equation and the other side will be 0. I'm going to choose to bring everything to the right. So I get x squared, then 3x plus 1 is 4x minus 2 gives me 2x. And then my constant, 2 minus 1 is 1. 1 minus 4 is minus 3. Now I can factorize. X plus 3, x minus 1. And therefore, x is going to equal to negative 3, or x is going to equal to 1. Now, normally, this would be the end of my question. However, when you have an x's in the denominator, you need to think about if you have any restrictions. So let's go back to my lowest common denominator. In my lowest common denominator, if any of my values, if I've got x is equal to negative 1, or x is equal to 1, or x is equal to negative 2, if x is any of those values, it will change my denominator into 0. And in maths, it's undefined if we divide by 0. So if I go back to my answer, I can see that x plus 1 is actually excluded because x may not be any of those. So as my final answer, therefore, x is negative 3 only. This brings us to literal equations. Now, literal equations are equations where instead of having constants and one variable, you have many variables, and you want to write the equation with one of the variables being the subject. So, looking at the first example, it looks a little bit terrifying with those fractions. So my suggestion is let's remove the fractions so that we can free up the x's, because the aim is to solve for x. And at the moment, x is sitting in the numerator. So the way to undo this equation would be probably to make the same denominator so I can free the x up. So my same denominator will be PQ. I'm going to show all my fractions just to help you a little bit. PQ minus PQ, it's equal to, next fraction is PQ. Now the first fraction, I would need to multiply by Q, top and bottom. The second fraction, to make my denominator PQ, I'd need to multiply by P, top and bottom. And the last fraction has a denominator of 1, so I'd need to multiply top and bottom by PQ to give them all the same denominator. Now let's multiply by my lowest common denominator, which is PQ. So we're going to get QX minus PQ minus PX. Negative P times negative Q is plus PQ. And on the right, because I don't have any x's involved, I'm not actually going to multiply this out. I'm just going to leave it like it is. So let's look back on the left. I've got PQ and minus PQ, which will make 0. So on the left, I've got QX minus PX is equal to PQ times Q minus P. And because I'm solving for x, let's take out x as a common factor. Q minus P. The right I'm just going to leave like it is. And next, I'm going to divide both sides by whatever x is times by, because I'm doing an opposite action to get rid of the Q minus P on the left. Now, interestingly enough, because I didn't multiply out, I can actually see that Q minus P and Q minus P divide with each other. So I'm going to get x is equal to PQ. So if we look back at this question, there's multiple strategies I used. Firstly, I eliminated the fraction to make my life a little bit easier. The reason why I eliminated the fraction is because x was sitting in the fraction, in the numerator. On the right, I didn't multiply this out because it didn't really matter if I did or didn't. It just helped me to leave it like it was. Next, when I got to this step, I made x a common factor so that I could isolate the x, because the aim of the equation is to isolate the x. And then I divided both sides by what x was being multiplied by, and I got x as pq. Remember inverse operations when you're solving literal equations. Plus is opposite to minus, times is opposite to divide, squaring is opposite to square rooting, which brings me to the last question. The equation in this example probably looks quite familiar to you. It's the equation for compound interest, and I've been asked to make I the subject of the formula. In other words, I want to isolate I. Now let's think about what's happening to I here. Firstly, I would add 1 to I. Then, next, I am putting it to the power of n. And lastly, I'm multiplying by p. Because remember, power only applies to exactly what it's next to. It doesn't apply to everything unless there's a bracket. So, in order to undo this equation, I'm going to have to work backwards. I'm going to have to do the opposite. Divide by p, square root or root of n, and then minus 1. So let's work slowly. Let me just write down the question again. The first piece I'm going to move away to isolate the I is the p. Now p is being multiplied by that bracket, so the opposite of multiplying is going to be dividing. So I'm going to get a over p is equal to 1 plus I to the power of n. Now the next step to isolate the I will be to get rid of the n power. Now the opposite of the n power will be the nth root. So I'll say nth root of a over p is equal to 1 plus I. Now the last step to isolate the I will be to get rid of the 1. Now 1 is being added to I, so the opposite of adding I to 1 will be subtracting I from 1. So I'll say the nth root of a minus p minus 1. And that will be I as the subject of the formula. So hopefully you'll have found this review helpful. Remember, if you've got an equation with x to the power of 1, you normally put the x's on one side and the values on the other. If you've got an equation where you've got x squared, a quadratic equation, everything must come to one side and set equal to 0. If you've got an equation with fractions, multiply both sides by the lowest common denominator. And lastly, with literal equations, it's a good strategy to try and undo the equation slowly so that you can solve for the variable you're looking for.